vintage in JUnit. Now we are focusing on vintage. JUnit Vintage provides a test engine for running JUnit 3 and JUnit 4 based tests on the platform. It requires JUnit 4.12 or later to be present on the class path or module path. Here you can see the monolithic architecture of JUnit 4, a single jar file, JUnit.jar. JUnit 4, released in 2006, has a simple monolithic architecture. All its functionality is concentrated inside a single jar file. A programmer wants to use JUnit 4 in a project. If a programmer wants to use JUnit 4 in a project, all they need to do is add that jar file on the class path. Here you can see JUnit.jar. Here you can see JUnit 3.8.x patterns summary. The goals of JUnit. What are the goals of JUnit? First, we have to get back to assumptions of development. If a program feature lacks of automated test, we assume it doesn't work. This seems much safer than prevailing assumption that if a developer assures us a program feature works, then it works now and forever. From this perspective, developers aren't done when they write and debug code. They must also write tests that demonstrate that the program works. However, everybody is too busy. They have too much to do. They don't have enough time to screw around with testing. So the number one goal is to write a framework within which we have some glimmer of hope that developers will actually write tests. The framework has to use familiar tools, so there is little new to learn. It has to require no more work than absolutely necessary to write a new test. It has to eliminate duplicated effort. If this was all test had to do, you would be done just by writing expressions in a debugger. However, this isn't sufficient for testing. Telling me that your program works now doesn't help me, because it doesn't assume me that your program will work 1 minute from now after I integrate, and it doesn't assure me that your program will still work in 5 years when you are long gone. So the second goal of testing is creating tests that retain their value over time. Someone other than the original author has to be able to execute the test and interpret the result. It should be possible to combine tests from various authors and run them together without fear of interference. Finally, it has to be possible to leverage existing tests to create new ones. Creating a setup or fixture is expensive, and a framework has to enable reusing features to run different tests. The design of JUnit will be presented in a style first used in. The idea to explain the design of a system by starting with nothing and applying patterns one after another until you have the architecture of the system. We will present the architectural problem to be solved, summarize the pattern that solved it, and then show how the patterns was applied to JUnit. Test case. First, we have to make an object to represent our basic concept, the test case. Developers often have test cases in mind, but they realize them in many different ways. Print statements, debugger expressions, test scripts. If we want to make manipulating test easy, we have to make them objects. This takes a test that was only implicit in the developer's mind and make it concrete, supporting our goals of creating tests then retain their value over time. At the same time, the object developers are used to well developing with objects, so the decision to make test into object supports our goal of making test writing more inviting, or at least less imposing. The command pattern fits our needs more nicely. Quoting from the intent, encapsulate a request as an object, thereby letting you queue or log request. Commands tell us to create an object for an operation and give it a method to execute. To illustrate the evolution of JUnit, we use diagrams that show snapshot of the architecture. Because we expect this class to be reused through inheritance, we declare it a public abstract. For now, ignore the fact that it implements the test interface. For the purpose of our current design here, you can think of test case as a long class. For every test case is created with a name, so it a test fails, you can identify which test fails. The notion we use is simple. It annotates classes with shaded boxes containing the associated pattern. When the role of the class is in the pattern, it is obvious, then only the pattern name is shown. If the role isn't clear, then the shaded boxes are augmented by the name of the particular participant this class responded to. This notation minimizes the clutter in diagram and was first shown in here. This shows this notation applied to here to test case. Blanks to fill in and run. The next problem to solve is giving the developer convenient place to put their fixture code and their test code. The declaration of test case as an Abstract says that the developer is expected to reuse the test class by subclassing. However, if all we could do was to provide the superclass with one variable and no behavior, we wouldn't be doing much to satisfy our first goal, making test easier to write. Fortunately, there is a common structure to all tests. They set up a test fixture, run some code against the fixture, check some results, and then clean up the fixture. This means that each test will run with a fresh fixture, and the results of one test can't influence the result of another. This supports the goal of maximizing the value of the tests. Template method addresses our problem quite nicely. Quoting from the intent, define the skeleton of an algorithm in an operation, differing some steps to subclasses. Template method lets subclass just redefine certain step to an algorithm without changing the algorithm's structure. This exactly right. We want the developer to be able to separately consider how to write the fixture, setup, and tear down code, and how to write the testing code. The execution of this sequence, however, will remain the same for all tests, no matter how the fixer code is written or how the testing code is written. The default implementation of these methods do nothing. Since setup and tear down are intended to be overridden but will be called by the framework, we declare them as protected. The second snapshot, here you can see the template method here. The template, reporting test result. If the test case runs in a forecast, does anyone care about the result? Sure, you run the test to make sure they run. After the test has run, you want a record, a summary of what did and what didn't work. If test had equal chances of succeeding or failing, or if we only ever ran the one test, we could just set a flag in the test case object and go look at the flag when the test completed. However, tests are intended to be highly asymmetric. They usually work. Therefore, we only want to record the failures and a highly condensed summary of the success. The Smalltalk best practice patterns has a pattern that is applicable. It is called collecting parameter. It suggests that when you need to collect results over several methods, you should add a parameter to the method and pass an object that will collect the result for you. We create a new object, test result, to collect the result of running test. This simple version of test result only counts the number of tests run. To use it, we have to add a parameter to the test case.run method and notify the test result that the test is running. and the test result has to keep track of the number of tests to run. We declare the test result method start test as synchronized so that the single test run can collect the result safely when the tests are run in a different threads. Finally, we want to retain the simple external interface of test case. So we create a no parameter version of run that create its own test result. If tests always run correctly, then we wouldn't have to write them. Tests are interesting when they fail, especially if we didn't expect them to fail. What's more, tests can fail in ways that we expect. For example, by computing an incorrect result, or they can fail in more spectacular ways. For example, by writing outside of bound of an array. No matter how the test fails, we want to execute the follow test. JUnit distinguishes from failures and errors. Possibility of a failure is anticipated and checked for with assertions. Errors are anticipated problems like an array index out of bound exception. Failures are signals with an assertion failed error to distinguish and yeah. JUnit comes with a different implementation of test result. The default implementation counts the number of failures and errors and collects the results. The text results collects the results and present them in a textual form. Finally, the UI test UI test result is used by the graphical version of JUnit test runner to update the graphical test status. The test results is an extension point of the framework. Client can define their own custom test classes. For example, an HTML test result reports the result as an HTML document. Now stupid subclasses test case again. We have applied command to represent a test. Command relies on a single method like execute called run in the test case to invoke it. The simple interface allows us to invoke different implementation of a command through the same interface. We need an interface to generally run our test. However, all test cases are implemented as a different method in the same class. This avoids the unnecessary proliferation of classes. A given test class may implement many different methods, each defining a single test case. Each test case has a descriptive name like test money equals or test money add. The test cases don't conform to a simple command interface. Different instances of the same command class need to be invoked with a different methods. Therefore, our next problem is to make all test cases look the same from the point of view of the invoker of the test. Reviewing the problems addressed by the available design patterns, the adapter pattern springs to mind. Adapter has the following intent: convert the interface of the class into another interface clients expect. This sounds like a good match. Adapter tells us different ways to do this. One of them is a class adapter, which uses subclassing to adapt the interface. For example, to add test money equals to run test. We implement the subclass of money test and override the run test to invoke test money equals. To use the subclassing requires us to implement the subclass for each test case. We put an additional burden on the tester. This is against the JUnit goal that the framework should make it as simple as possible to add the test case. In addition, creating a subclass for each testing method results a class bloat. Many classes with only a single method are not worth their cost, and it will be difficult to come up with meaningful names. Java provides anonymous inner classes, which provide an interesting Java-specific solution to the class naming problem. With anonymous inner classes, we can create an adapter without having to invent a class name. This is much more convenient than full subclassing. It prevents compile time type checking that at the cost of burden on the developer. Smalltalk best practice patterns describe another solution for the problem of different instances having differently under common heading or pluggable behavior. This idea is to use a single class which can be parameterized to perform single different logic without requiring subclassing. The simple form of pluggable behavior is the pluggable selector. Pluggable selector stores a Smalltalk method selector in an instance variable. This idea is to limit is not limited to Smalltalk. This is also applicable to Java. In Java, there is no notion of method selector. However, the Java reflection API allows us to invoke a method from a string representing method name. We can use this feature to implement a pluggable selector in Java. As an aside, we usually don't use reflection in ordinary application code. In our case, we are dealing with an infrastructure framework, and it is therefore okay to wear the reflection hat. JUnit offers the client the choice of using pluggable selector or implementing an anonymous adapter class. To do so, we provide the pluggable selector as an default implementation of a run method, run test method. In this case, the name of the test case has to correspond to the name of the test method. We use reflection to invoke the method, and first we look up the method object. Once we have the method object, we can invoke it and pass it to argument. JDK 1.1 reflection API only allows us to find public method. For this reason, you have to declare test methods as public, otherwise you will get no such method exception. Don't care about one or many test suite. To get confidence in the state of a system, we need to run many tests. Up to this point, JUnit can run a single test case and report the result in a test result. Our next challenge is to extend it so that it can run many different tests. This problem can be solved easily when the invoker of the test doesn't have to care about whether it runs one or many test cases. The popular pattern to pull out in such situation is composite. To quote this intent, composite objects into a tree structure to represent part whole hierarchies. Composite lets client treat individual objects and compositions of object uniformly. The point about part whole hierarchies is of interest here. We want to support suits of test. Composite introduces the following participant component, declares the interface we want to use to interact with our tests. Composite implements this interface and maintains the collection of tests. Leaf represent test case in a composition that conforms to the component interface. The pattern tells us to introduce an abstract class which defines the common interface for a single and composite object. The primary purpose of the class is to define an interface. When applying composite in Java, we prefer to define an interface, not an abstract class. Using an interface, avoid committing JUnit to a specific base class for tests. To all that is required is that the test conform to this interface. Test case corresponds to a leaf in a composite and implements the interface as we have seen above, here. Next, we introduce the composite participant. We name this class test suit. A test suit keeps its child test in a vector. The run method delegates to its children. Finally, the client have to be able to add test to the to a suit. They can do so with the method add test. Notice how all of the these things only depends on the test interface. Since both test case and test suit conforms to the test interface, we can recursively compose suits of test suits. All developers can create their own test suits. We can run them all by creating test suits composed of those suits. This works fine, but requires to add all the tests to a suit manually. Early adapters of JUnit told us this was stupid. However, you can write a new test case. You have to remember to add it to a static shoot method. Otherwise, it will not be run. We added a convenient constructor to test shoot, which make the test case class as an argument. Its purpose is to extract the test methods and create a suite containing them. Test methods must follow the simple conventions. They start with the prefix test and take no arguments. The convenience constructor uses this convention, constructing a test object by using reflection to find the testing method. The original way is still useful when you want to run subset of test cases only. So here we are at the end of this JUnit tour with JUnit 3.8.x. This figure shows the design of JUnit at a glance, explained with patterns here. Notice how test case, the central abstraction in the framework, is involved in 4 patterns. The pictures of mature object design shows this same pattern density. The star of this design has a rich set of relationships with the supporting players. Here you can see the test interface here. It's a composite component here. Here you can see 2 subclasses. This test case and test suits is inherited from test. Test case has command pattern, template pattern, and composite leaf here, and pluggable selector. And test suit has a composite, and it has run method and add test method. Test suit composite of tests. Test case has run method, run test, setup and tear down, and pluggable selector fname. Test case is connected to test result. Here it has a collecting parameter pattern, and this one is inherited from test case, and it has this class. This follows the adapter pattern. It has run test method. As an example, we can consider org.junit.vintage. It's in Marmon repository. It's the group ID here, org.junit.vintage. It's in the group JUnit vintage. The group description is JUnit vintage. Here you can see JUnit 3 test case. The class test case, a test case defines the fixture to run multiple tests. To define a test case, step 1, implement a subclass of test case. Step 2, define instance variables that store the state of the fixture. Step 3, initialize the fixture state by overriding setup. So it's already set up. Step 4, clean up after a test by overriding tear down method. Overriding tear down. Each test runs in its own fixture, so there can be no side effects among test runs. For each test, implement a method which interacts with the fixture. Once the methods are defined, you can run them. The framework supports both the static type safe and more dynamic way to run a test. In a static way, you override the run test method and define the method to be invoked. The convenient way to do is with an anonymous inner class. The dynamic way uses reflection to implement run test. It dynamically finds and involves a method. In this case, the name of the test case has to correspond to the test method to be run. The test to be run can be collected into a test suite. JUnit provides different test runners which can run a test suite and collect the results. A test runner either expects a static method suite as an entry point to get a test to run, or it can extract suite automatically. Assert not null method asserts that an object isn't null. Assert false asserts that an condition is false if it isn't throws throws an assertion failed error. Assert equals here. Assert that two objects are equal here, expected and actual here. If they are not, an assertion failed error is thrown. A JUnit test case extend the JUnit test API class test case, and each test method must start with the word test. To run the tests in Eclipse, right-click on the test class in the Package Explorer view and choose Run as JUnit test. As an example 3, we can consider this JUnit 4 test case. The annotation type test. The test annotation tells JUnit that the public void method to which it is attached can be run as a test case. To run the method, JUnit first construct a fresh instance of the class, then invokes the annotated method. Any exception thrown by the test will be reported by JUnit as a failure. If no exceptions are thrown, the test is assumed to have succeeded. In exception testing, the parameter expected declares a test method should throw an exception. If it doesn't throw an exception, or if it throws a different exception than the one declared, the test fails. Using the parameter expected for exception testing comes with some limitations. Only the exceptions type can be checked, and it is not possible to precisely specify the code that throws the exception. Therefore, JUnit 4 has improved its support for exception testing with assert.assertThrows class throwing runnable and the expected exception rule. With assert_throws, the code that throws the exception can be precisely specified. If an exception message or one of its properties should be verified, the expected exception rule can be used. Timeout. The parameter timeout causes the a test to fail if it takes longer than a specified amount of clock time measured in milliseconds. Warning: while timeout is useful to catch and terminate infinite loops, it should not be considered deterministic. Thread safety warning: test methods with timeout parameter are run in a thread other than the thread which runs a fixture ampersand before and ampersand after methods. This may yield different behavior for code that is not thread safe when compared to the same test method without a timeout parameter. Consider using timeout rule instead, which ensure the test method is run on the same thread as the fixtures ampersand before and ampersand after methods. To run to your JUnit 3 or 4 test as is on the JUnit platform, simply include JUnit vintage dependency in your build and it just works. The Maven POM and Gradle build file build.gradle that are included with the same application already do this. You can run test right out of the box. In JUnit 4, a JUnit 4 test case ends with the word test. Here it is omitted here, and each test method is annotated with ampersand test. To run this test in Eclipse, right click on the test class in the package explorer view and choose run as, then JUnit test. Assert not null asserts that an object isn't null if it is an assertion error. If it is an then an assertion error is thrown. Assert false method asserts that a condition is false. If it isn't, it throws an assertion error without a message. Assert equals asserts that two longs are equals. If they are not, an assert error is thrown. This is the expected long value, and this is the actual long value. As an example 4, we can consider this Gradle segment here. The JUnit platform can run JUnit 4 base test as long as you configure test implementation dependency on JUnit 4 and test and runtime only dependency on JUnit vintage test engine implementation, similar to following here. And here org.junit.vintage, this is the group ID. As an example 5, we can consider this Maven segment. Maven Surefire and Maven failsafe can run JUnit 4 based test alongside Jupyter test as long as you configure test scoped dependencies on JUnit 4 and JUnit vintage test engine implementation similar to following. And here you can see JUnit vintage group ID. This is JUnit vintage here. As an exception example, we can consider this code segment. This is a test exception in JUnit 3. Here you can see the public string get message method. This returns the detailed message string of this throwable. Here assert equals asserts the two strings are equal here. It's expected and this is actual. As an exception, example 2, we can consider this one, test exception in JUnit 4. The class expected exception rules, the class expected exception, the expected exception rule allows you to verify that your code throws a specific exception. This is in package org.junit.rules in version JUnit 4. This is available from version 4.7. You have to add expected exception rule to your test. This is here. This doesn't affect your existing tests. After specifying the type of the expected exception, your test is successful when such an exception is thrown, and it fails if a different or no exception is thrown. This rule does not perform any special magic to make an execution continue if the exception had not been thrown. If it is nearly always a mistake for a test method to have a statement after the one that is expected to throw the exception. Instead of specifying the exception type, you can characterize the expected exception based on other criteria too. The exception message contains a specific test. Here expect message and a string. The exceptions message compiles with the hamcrest matcher, expect message matcher, or the exception cause compiles with the hamcrest matcher, expect cause matcher. The exception itself compiles with the hamcrest matcher, expect matcher. You can also combine any of the presented expect methods. The test is successful if the specifications are met. It is recommended to set order of the expected exception to integer dot max value if it is used together with another rule that handles the exception, for example error collector. Otherwise failing test may be successful. The assumption violated exceptions. JUnit uses assumption violated exceptions for indicating the test provide no useful information. You have to call assume method before you set expectations of the exception rule. In this case, the rule will not handle consume the exceptions, and it will handle by the framework. Now you can see here the test runner for running test in JUnit 4. JUnit is a simple open source unit testing framework tool to write and run repeatable unit tests. Also, it is an instance of the XUnit architecture for unit testing framework. It is mostly used as the unit testing tool by most developers. The main features are as below. The annotations to mark the method as the test methods, assertions for testing expected results and actual results. The test runner for running test are as shown below this picture. Here the code repository is connected to source code and unit tests. Here the source code is connected to test runner and unit test is connected to test runner. Invoke test is are connected to test runner, and test runner is connected to reports. Here you can see the different the JUnit 5 versus JUnit 4. Here the before hole instead of before class, and at after all instead of at after class, and at before each instead of at before, and at after each instead of at after, at disable instead of at ignore, at tag instead of at category, assert throws instead of expected attribute, assert timeout instead of timeout attribute. Here the annotation type before class. Sometimes several tests need to share computationally expensive setup like logging into a database. While this can compromise the independence of test, sometimes it is a necessary optimization. Annotating a public static void no arg method with at before class causes it to be run once before any of the test method in the class. The at before class methods of super classes will be run before those of the current class unless they are shadowed in the current class. Annotation type after class. If you allocate expensive internal resources in a before class method, you need to release them after all the tests in the class have run. Annotating a public static void method with an at after class causes that method to be run after all tests in the class have been run. All after class methods are guaranteed to run even if a before class method throws an exception. The after class methods declared in superclasses will be run after those of the current class unless they are shadowed in the current class. Annotation type before. When writing test, it's common to find several test need similar objects created before they can run. Annotating a public void method with at before causes that method to run before the test method. The at before methods of superclasses will be run before those of the current class unless they are overwritten in the current class. No other ordering is defined. If you annotation type after in org.JUnit, if you allocate external resources in a before method, you need to release them after the test runs. Annotating a public void method with at after classes causes that method to be run after the test method. All at after methods are guaranteed to run even if a before or test method throws an exception. At after methods declared in a superclass will be run after those of the current class unless they are overridden in the current class. Annotation type ignore. Sometimes you want to temporarily disable the test or group of tests. Method annotated with tests that are also annotated with at ignore will not be executed as tests. Also, you can annotate class containing test method with at ignore and none of the containing test will be executed. Native JUnit for test runners should report the number of ignored tests along with the number of tests that ran the number of tests that failed. Annotation type category marks a test class or test method as belonging to one or more categories of test. The value of an array value is an array of arbitrary classes. This annotation is only interpreted by categories runner at present. Here you can see the annotations in JUnit 4. There are two main abstract model for JUnit framework. One of it is the abstract of test unit. Each test unit has its own scope, name, initial state, and the way how to release the resources which are allocated during the testing time. The JUnit 4 it uses inheritance models to represent that concept. With the annotation, the framework use reflection to get the meta information of the test unit. The class has its own member, so JUnit use abstract method abstract class framework member to represent it. The class member can be classified into a field and method. JUnit uses framework field and framework method which inherit from framework member. Framework field maintain a private object of class field which is used in reflection. So do framework method. Here the can see the interface annotatable in dog.junit.runners.model, a model element that may have annotations. Here the framework, the class framework member type parameter t, extend framework member type parameter t. Here the class framework method represent a method on a test class to be invoked at the appropriate point in test execution. These methods are usually marked with an annotation such as at test, at before, at after, at before class, at after class, etc. Here class framework method in JUnit.runners.model represent a method that on a test class to be invoked at appropriate point in test execution. These methods are usually marked with an annotation such as at test, at before, at after, at before class, at after class, etc. Class test class wrap a class to be run, providing method validation, annotation, searching. Here you can see the interface annotatable. The implementing classes are framework member, test class, and there are other two implementation class, test class, and here the framework here the framework class framework framework member. Here the direct known subclasses, framework method and framework field. Here you can see an important inheritance in JUnit 4. JUnit test I started using JUnit core class. It will can run us to finish the tasks. Other important inheritance shown here. The public class all default possibilities builder, extend, runner builder will be called and try to find runners to run test classes which are written by user. Finally, block JUnit 4 class runner will be called. Here you can see the interface filterable in org.gen.runner.manipulation. The runners that allow filtering should implement this interface. Implement filter to remove tests that don't pass the filter. The interface describable in jog.junit.runner represent an object that can describe itself. The interface sortable in org.junit.runner.manipulation. Interface for runners that allow sorting of tests. By sorting tests based on when they last failed, most recently failed first, you can reduce the average time to the first test failing. Test sorting should not be used to cope with the order dependencies between tests. Tests that are isolated from each other are less expensive to maintain and can be run individually. Class runner. A runner runs test and notifies a run notifier of significant event as it does so. You will need to subclass runner when using run with to invoke a custom runner. When creating a custom runner, in addition to implementing the abstract method here, you must provide the constructor that takes an argument the class contained in the test. The class parent runner type parameter t provides most of the functionality specific to the runner that implements the parent node in the test tree with children defined by object of same data type t. For block JUnit for class runner, t is method, and for suit t is class. Subclasses must implement finding the children of the node, describing each child and running each child. Parent runner will filter and sort children, handle at before class, at after class method, handle annotated class rules, create composite description, and run children sequentially. The class block JUnit for class runner in org.junit.runners implements the JUnit for standard test case class model as defined by the annotations in the org.junit package. Many users will never notice this class. It is now the default test class runner, but it should have exactly the same behavior as the old test runner, JUnit for class runner. The class JUnit 4 aliases the current default JUnit 4 class runner. For future proofing, the future versions of JUnit change the default runner class. They will also change the definition of this class. Developers wanting to explicitly tag a class as a JUnit 4 class should run with JUnit4.class, not for example in JUnit 4.5. The class block JUnit for class runner with parameters in org.junit.runners.parameterize. A block class for class runner with parameters support. Parameters can be injected via constructor or an annotated fields. The class suit in org.junit.runners. Using suit as a runner allows you to manually build a suit containing tests from many classes. It is the JUnit 4 equivalent of the JUnit 3.8.x static test suit method. To use it, annotate the class with at run with suit.class and at suit classes test class 1.class etc. When you run this class, it will run all the tests in all the suit cases. Class parameterize in org.junit.runners. The custom runner parameterize implements parameterized tests. When running parameterized test class, instances are created for each cross product of the test method and the test data elements. Here the parent runner implemented the interface, the implemented interfaces are here filterable and sortable. And the superclass is runner, and runner implements desirable interface. Parent runner has subclasses block JUnit for class runner and suit. Block JUnit 4 class runner has subclasses JUnit 4 and block JUnit 4 class runner with parameters, and suit has subclass parameterize. Here you can see the life cycle of JUnit 4. Here the before class an annotated public static void no argument method will be executed before execution of any test method in the class. At after class, an annotated public static void no argument method will be executed after all test methods of this class are executed. At before, this method will be called before each test method in the class. At after, this method will be called after each test method in the class. The annotation type before class. Sometimes several tests need to share computationally expensive setup like logging into database. While this can compromise the independence of tests, sometimes it is necessary optimization. Annotating a public static void no arg method with at before class causes it to be run once before any test method in the class. The at before class method of superclasses will be run before those of the current class unless they are shadowed in the current class. Annotation type before. When writing tests, it is common to find that several tests need similar objects created before they can run. Annotating a public void method with the before at before causes that method to run before the test method. The at before method of superclasses will be run before those of the current class. Unless they are overridden in the current class, no other ordering is defined. The annotation type test. The test annotation tells JUnit that the public void method to which it is attached can be run as a test case. To run the method, JUnit first constructs a fresh instance of the test class, then invokes the annotated method. Any exceptions thrown by the test will be reported by JUnit as a failure. If no exceptions are thrown, the test is assumed to have been succeeded. have succeeded. The annotation type after, if you allocate external resources in a before method, you need to release them after the test runs. And annotating a public void method with after causes that method to be run after test method. At after method are guaranteed to run even if at before or test method throws an exception. At after methods declared in superclasses will be run after those of the current class unless they are overridden in the current class. Annotation type after class, if you allocate expensive external resources in a before class method, you need to release them after all tests in the class have run. Annotating a public static void method with at after causes that method to be run after all the tests in the class have been run. All at after class method are guaranteed to run even if a before class method throws an exception. The at after class method declared in superclasses will be run after those of the current class unless they are shadowed in the current class. Here you can see the test class lifecycle. Start is connected to at before class. At before class is connected to here the for each and here for each at test case. Here you can see the at before and then at test, and after that then at after, then it's connected to at after class and then end. Now we are focusing on JUnit 4.12. As an example, we can consider this code segment. Here the annotation type test. The test annotation tells JUnit that the public void method to which it is attached can be run as a test case. To run the method, JUnit first construct a fresh instance of the class, then invokes the annotated method. Any exceptions thrown by the test will be reported by JUnit as a failure. If no exceptions are thrown, the test is assumed to have succeeded. This is in the package package org.junit. As an example 2, we can consider this Maven segment. Maven Surefire and Maven Failsafe can run JUnit 4 based test alongside Jupyter tests as long as you configure test scope dependencies on JUnit 4 and the JUnit vintage test engine implementation similar to following here. And you can see here JUnit 4 and the scope test. Now we are considering here the annotation interface type enable JUnit for migration support in package org.junit.jupyter.migration support in module org.junit.jupyter.migration support. Enable JUnit for migration support is a class level annotation that enables all JUnit for migration support within JUnit Jupyter. I included this here basically for the annotation, but this is in the JUnit org.junit.jupyter. Now we are considering category support in running JUnit 4 test on the JUnit platform in migrating from JUnit 4 for test classes or methods that are annotated with at category. The JUnit Vintage test engine exposes the category fully qualified class name as a tag for the corresponding test class or test method. For example, if a test method is annotated with, like here, the category here example.class, it will be tagged with here com.seme.example. Similar to the categories runner in JUnit 4, this information can be used to filter the discovered test before executing them. Now we are considering migration tips. The following are the topics that you should be aware of when migrating existing JUnit 4 test to JUnit Jupyter. Annotations reside in the org.junit.jupyter.api package. Assertions reside in org.junit.jupyter.api.assertions. Note that you may continue to use the assertion method from org.junit.assert or any other assertions library such as assert j, hamcrest, truth, etc. Assumptions reside in org.junit.jupyter.api.assumptions. Note that the Jupyter 4.5.4 and other versions support method from JUnit's 4's org.junit.assume class for assumptions. Specifically, JUnit Jupyter supports JUnit 4's assumption violated exception to signal that the test should be aborted instead of marked as failure. At before and at after no longer exist, used at before each, at after each instead. At before class and at after class no longer exist, used at before all and at after all instead. Ignore no longer exist, used at disabled or one of the other built-in execution condition instead. At category no longer exist, use at tag instead. At run with no longer exist, superseded by at extend with. At rule and at class rule no longer exist, superseded by at extend with and at register extension. At test expected equal etc. And the expected exception rule no longer exist. Use assertions dot assert throws instead. Assertions and assumptions in JUnit Jupyter accept the failure message as their last argument instead of the first one. Now we are considering JUnit for rule support. This limited form of rule support can be switched on by the class level annotation at enable rule migration support. The annotation interface at enable rule migration support in package org.junit.jupyter.migration support.rules in module org.junit.jupyter.migration support rules. This annotation is in Jupyter. As stated before, the JUnit Jupyter does not and will not support JUnit 4 rules natively. The JUnit team realizes, however, that many organizations, especially large ones, are like to have large JUnit 4 codes bases that makes use of custom rules. To serve these organizations and enable a gradual migration path, the JUnit team has decided to support the selection of JUnit 4 rules verbatim within JUnit Jupyter. The support is based on adapter and is adapters and is limited to those rules that are semantically compatible to JUnit Jupyter extension model. That is, those do not have completely changed the overall execution flow of the test. The JUnit Jupyter migration support module from the JUnit Jupyter currently supports the following 3 rule types, including subclasses of these types: org.junit.rules.external resource, including org.junit.rules.temporary folder, org.junit.rules.verify, including org.junit.rules.error collector, org.junit.rules.expected exception. As in JUnit 4, rule annotated fields as well as methods are supported. By using these class level extensions on the test class, such rule implementation in legacy code bases can be left unchanged, including JUnit 4 rule import statement. This limited form of rule support can be switched on by the class level annotation at enable rule migration support. This annotation is composed annotation which enable all rule migration support extensions, verifier support, external resource support, and expected exception support. You may alternatively choose to annotate your test class with at enable JUnit 4 migration support, which registers migration support for rules and JUnit 4's at IGNO annotation. However, if you intend to develop a new extension for JUnit Jupyter, please use the new extension model of JUnit Jupyter instead of rule-based model of JUnit 4. Now we are considering JUnit 4 at IGNO support. The IGNO condition is an execution condition that disables test classes or test method that are annotated with at IGNO. In order to provide a smooth migration path from JUnit 4 to JUnit Jupyter, the JUnit Jupyter migration support module provides support for JUnit 4's at IGNO annotation, analogous to Jupyter's at disable annotation. To use at IGNO with JUnit Jupyter based test, configure the test dependency on the JUnit Jupyter migration support module in your build, and then annotate your class with extend with IGNO condition class. So enable JUnit 4 migration support, which automatically registers the IGNO condition along with limited JUnit 4 rule support. The IGNO condition is an execution condition that disables the test classes or test method that are annotated with at IGNO. Now we are considering failure message argument. The method affected by this change are as follows. The assumptions and assertions classes in JUnit Jupyter declare argument in a different order than in JUnit 4. In JUnit 4, assertion and assumption method accept the failure message as first argument, whereas in JUnit Jupyter, assertion and assumption method accept the failure message as the last argument. For instance, the method assert equals in JUnit 4 declared as assert equals string message object expected object actual, but in JUnit Jupyter is declared as assert equal object expected object actual string message. The rationale for this is that failure message is optional and optional arguments should be declared after required arguments in the method signature. The method affected by this change are the following: assertions, assert true, assert false, assert null, assert not null, assert equals, assert not equals, assert array equal, assert same, assert not same, assert throws. Assumption: assume true, assume false. Test annotation supports two optional parameters for exception testing and for limiting test execution time. Here we are considering expected parameter for as an exception example here. The parameter expected declares that the test method should throw an exception. If it does not throw an exception, or if it throws a different exception than the one declared, the test fails. For example, this test succeeds here. Using the parameter expected for exception testing comes with some limitations. Only the exceptions type can be checked, and it is not possible to precisely specify the code that throws the exception. Therefore, JUnit 4 has improved its support for exception testing with assert throws class throwing runnable and the expected exception rule. With assert throws, the code that throws the exception can be precisely specified. If the exception's message or one of its properties should be verified, the expected exception rule can be used. As an error example, we can consider this one occurred in Android Studio, failed to resolve JUnit 4.12. Now we are focusing on JUnit Vintage engine. JUnit Vintage test engine implementation that allows one to run Vintage JUnit test on the JUnit platform. Vintage test includes those written using JUnit 3 or JUnit 4 APIs, or test written using testing frameworks built on those APIs. Core package for the JUnit Vintage test engine. Here you can see the dependency diagram. Here you can see JUnit Vintage engine in org.junit.vintage package. As an example, we can consider the module org.junit.vintage.engine. Provides a test engine for running JUnit 3 and 4 based test on the platform. As an example 2, we can consider org.junit.vintage.engine package, core package for the JUnit Vintage test engine. This is in module org.junit.vintage.engine. As an example 3, we can consider Vintage test engine. The class Vintage test engine, the JUnit Vintage test engine. This is available since version 4.12, and this is in the module org.junit.vintage.engine and in the package the org.junit.vintage.engine. As an example 4, we can consider this Gradle segment. The JUnit platform can run JUnit 4 base test as long as you configure test implementation dependency on JUnit 4 and test runtime only dependency on JUnit vintage test engine. Implementation similar to following, and here you can see artifact JUnit vintage engine. This is the module JUnit vintage engine of JUnit 5. This is in the group ID org.junit.vintage. As an example 5, we can consider this Maven segment. Maven Surefire and Maven failsafe can run JUnit 4 base test alongside Jupyter test as long as you configure test scope dependencies on JUnit 4 and the JUnit vintage test engine implementation similar to following here. And here you can see artifact JUnit artifact ID JUnit vintage engine here, the module JUnit vintage engine of JUnit 5 is in the group ID org.junit.vintage. Now we are considering additional Gradle dependencies in IntelliJ IDEA in IDE support in running test. Here the artifact JUnit vintage engine in group ID org.junit.vintage, a thin layer on top of JUnit 4 to allow running vintage tests based on the JUnit 3.8 and 4 JUnit 4 with the JUnit platform launcher infrastructure. Here you can see additional Maven dependencies. Now we are considering JUnit test engines in advanced topics. JUnit vintage engine, a thin layer on top of JUnit 4 to allow running vintage test based on JUnit 3.8 and JUnit 4 with the JUnit platform launcher infrastructure. Now we are considering JUnit vintage in dependency metadata. The artifact ID JUnit vintage engine in version here, for example 5.10.0 in group ID org.vintage org.junit.vintage. The JUnit vintage test engine implementation that allows one to run vintage JUnit test on the JUnit platform. Vintage tests include those written using JUnit 3 or JUnit 4 APIs or test written using testing framework built on those APIs. As an example, we can consider this one internal record and JUnit.platform.commons.JUnit exception, test engine with ID JUnit vintage failed to discover test, etc. As an error example, we can consider this java.lang.no such method error, org.junit.vintage.engine.descriptor.runner test description.get all descendants. As an error example 2, we can consider this error occurred in Spring Boot 2.2 and JUnit 5 environment. Failed to execute goal org.apache.maven.plugins.maven file sure plugin plugin 2.22.2 test default test on project xxx. There are test failures and etc. Then here please refer to the project workspace xxx target file. Surefire reports the individual test results. Please refer to the dump files if any exist. There was an error in the forked process. Test engine with ID JUnit vintage failed to discover test, etc.